Hello, welcome back. We're still in trigonometry. You can see that place is blank because for this lesson, I need something which I did a couple of lessons ago about the displacements or the graph of sine and cos. Let's look at the graph of sin x. If you look at the graph of sin x, oh, by the way, my name is Sosale Mohana. I'm a maths teacher, specializing, not exactly specializing, who has spent a considerable time teaching A-level maths for the British curriculum and before that the Indian curriculum, about 50 years plus. So I'm just using these lessons to help you revise what you learned in school. This is not a replacement of your classroom lesson. It's your teachers or your first resource. They have taught you everything. My job is only to go over what they have taught you so that you can revise and relearn or maybe reinforce what your teachers have taught you. I'm not replacing your teacher. Thank you. Let's come back. So today I'm trying to see methods of solving trig equations. Now, by the way, this one, different teachers use different methods. Do listen to it. If you find it a bit confusing, stick to the method your teachers have taught you. But no harm if you want to use this method, it will still work. And you get the marks in the exam, so it doesn't make a difference. Alright? So I leave it to you to decide which is the best way out. So I'm looking at the sine graph. So that's the sine graph. 0, 180, 360, 720, 900 and so on. And of course, minus 180, minus 360, minus 720 and so on. Suppose I'll take a simple example. The maximum is 1. I'll take half. In other words, how many values do you have to solve sine theta equal to half? 2 values, 4 values, 6 values. There are millions and billions and trillions of values, meaning it's infinitely many values because the graph never ends. That's why we give a domain between 0 and 360, or between minus 180 and 180, or between minus 360 and 360. Generally, we don't go beyond that. We have to solve. Okay? That means, let's say I want to solve from 0 to 360. I have 1, 2, 3, 4 solutions. Oh! Only 2. That's wrong. Idiot. 360 stops here. There's no solution there. So, from here to here, there are only 2 solutions. So, in other words, for sine theta, in an standard interval of 360 degrees, 0 to 360, there will be only 2 solutions. If you have 2 theta, there will be 4 solutions. If you have 3 theta, there will be 6 solutions. If you have half theta, there will be only 1 solution. So, the number of solutions will generally be double the angle. Similarly, between minus 180 and 180, again, maximum of 2 solutions, maximum of 4 solutions. So, you don't have to remember that if you don't want to, but let's see how we do it. Let's take a calculator and see how it works. Sin theta is half. From calculator, you know the answer is 30 degrees. So, that's one. Alright? Try to do sine 150. You will see sine 150 is also half. So, this angle is 150. That's 150. That's 180. Now, that difference is 30. That difference is 30. So, after 360, I can have an angle 30 there. I can have another angle 30 there. After 900 to 1080, I can have an angle there and I can have an angle there. 30, 30. If I go backwards, I have minus 180 and a minus 30, minus 360 and a plus 30. So I can keep off for positive values. I can go up. Oh, sorry, I can go down, meaning going to the right. So I can have 360 plus 30. It should be 540. That should be 720. That should be 900. Yeah. 360 plus 30, 540 minus 30, 720 plus 30, 900 minus 30, and so on and so on and so on. On the other side, minus 180 minus 30, minus 360 plus 30, minus 540 minus 30, minus 720 plus 30, ta 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 ta. In fact, in the exam, you can remember the pattern and find all the answers. However, let's see if all this can be combined into, remember I told you in maths we talk of only patterns. So if I write here 0 plus 30, would you be wrong? Nope. If I write here 180 minus 30, would I be wrong? No. Remember, the first value from the calculator was 30. In other words, your calculator, later on we will give the principal value of sine, which is between minus 90 and 90. If sine is positive, it will give you a positive angle. If sine is negative, it will give you the biggest negative angle or the smallest positive angle. Okay? So this, let's call this as alpha. So alpha, 180 minus alpha, 360 plus alpha, 540 minus alpha, 720 plus alpha, 900 minus alpha, minus 180 minus alpha, minus 360 plus alpha, minus 540 minus alpha, minus 720 plus alpha, blah, 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 it goes on. So in other words, can I say sine theta equal to half can also be written as sine theta equal to sine 30, the smallest possible angle. So alpha is 30. Then all values are given by 180 minus alpha, 360 plus alpha. But let's go a bit further. Can I write 180 as 180 times 1 minus alpha? 360 can I write as 180 times 2 plus alpha? 540 can I write as 180 times 3 minus alpha? 720, 180 times 4 plus alpha. 900, 180 times 5 minus alpha. 0 is 180 times 0 plus alpha. 180 times minus 1 minus alpha. 180 times minus 2 plus alpha. 180 times minus 3 minus alpha. 180 times minus 4 plus alpha. Well, at least now we've got a pattern. Do you see the pattern there? Remember I told you most of maths is recognizing and identifying patterns to arrive at a general formula. So, I know definitely all values of theta are given by 180 times an integer. Maybe a positive integer or maybe a negative integer. So, I can call it as n. But, when you use n as an even number, like minus 4, minus 2, when n is even, minus 4, minus 2, 0, 2, 4, it's all positive. When it is odd, minus 3, minus 1, 1, 3, 5, it's all negative. So remember, minus 1 power odd number is minus, minus 1 power even number is plus. So I can combine this as minus 1 power n alpha. But I don't like alpha. We normally call it as the principal value. That means the very first value you get from the calculator, we call it as PV. Now some students say, sir, minus 1 power n, I can't remember. It's a bit difficult. No problem. There is an easier way. I'm going to the same thing. So, only for sine this works. The principal value is alpha, which is 30 degrees. The next value is 180 minus alpha, 150. We call the secondary value is 180 minus alpha, which is 150. Now look, 0 plus 30, 360 plus 30, 720 plus 30. Yeah. So, I could write it as 180 plus PV, 180 plus SV. Does it work? Okay. 180 plus 30. Yeah. 180 times 2 plus 30. 180 times 3 plus 30. 180, sorry, times 4 plus 30. 180 times 6 plus 30. It works. But what about others? 150, 180 plus 150 is 180 plus 180 minus 30. I'm looking at the value 540 minus 30. Sorry, 360 minus 30. Ooh, that doesn't seem to be working. So, how do we? Let's list it and see what will happen. Okay, let me put all the 30 degrees ones. Like, 30, 360 plus 30, 720 plus 30, 1080 plus 30, minus 360 plus 30, minus 720 plus 30, then minus 1080 plus 30. Very good. What are these are the values? That means I'm not worried about the even values. My problem is not the even values, but the odd values. I need to cancel this off. I don't want to rub them. It might look confusing, but later on you don't have to do any of these things. I'm trying to build a shortcut for you. So the other one is 150. Yeah. Now I've got 540 minus 30 is 510. Don't you think this is 360 plus 150? Yeah. No, 900 minus 30 is 870. What is 720 plus 150? So the way you did this, I'm doing the same thing. So I can stick to multiples of 360 and either add the principal value or add the secondary value. That is what I would prefer, because I don't like that minus 1 power n is confusing. As I said, you don't have to know any of these things, but it's wrong on my part to just give you an answer without showing how I deduce the answer. That's why I'm doing it. I'm not going to waste your time, because ultimately, as long as you know the formula, you don't, like, something like in India, we say, in the exam, the examiner doesn't want you to prove a formula, because there was a time when students had to prove a particular general formula. You might still do it at university level, but at A level, as long as you get the right answers using a right method or a right formula, they're not bothered. Because there are so many, as I told you, there are so many. Some teachers use the quadrant method, some teachers use the circle method. I prefer this. So therefore, I can put to solve sine x equal to k. I will write this and leave it there because I need it for the next lesson as well. So therefore, step 1. Find arc sine k. I am going to introduce you to this, or sine inverse k from calculator. Call the answer is PV, principal value. Later on, when I read the other formula, I will just write PV and SV. Okay. Then step 2. Find SV equal to 180 minus PV. SV is secondary value. Okay. Then, what the advantage of this method? When I take a question, I will show you secondary value. Therefore, then all values of x are given by x equal to 360n plus PV, 360n plus SV, where n belongs to z, the set of integers. So and depending upon the value, you can put values of n to pick angles within a particular range. That was a brief discussion for sine. Now I'm going to give you the formula for cos and tan. Don't worry, you don't have to copy all this because it's going to be in your formula, sorry, in your handout. This one will be a typed handout, not a handwritten handout. Alright? So let me rub this off. So remember the word PV, remember the word SV. You don't have to write all these things in the exam or your memory aid, you got to remember everything. To solve sin x equal to k, you must know mentally what is PV, what is SV. So you straight away say, the only thing I'll write is SV equal to 180 minus PV. So x equal to 360n plus PV, 360n plus SV. To solve cos x equal to k, I can go through the same argument and use one more lesson. Again, in the end, what we need is only the formula. So I've shown you how to derive, how to deduce or conclude the sine formula. You can try by drawing the cos graph how to look at the cos formula in your calculator. So I'm not going to do it. So here PV is cos inverse k. Here PV is sine inverse k. Please don't use a PV of sine inverse k when you're doing cos. If it is cos, PV will be cos inverse. If it is sine, PV will be sine inverse. This is x equal to 360n plus PV, 360n minus PV. And to solve tan x equal to k. X will be, of course, PV is tan inverse k. Px is equal to 180n plus PV. These are called the general solutions. There was a time when students had to know how to find a general solution or apply a general solution. Sometimes it was, arriving at a general solution for a combination of two functions. But fortunately or unfortunately, as far as I'm concerned, you don't have to know this. As I said, you won't find this in a formula book. I haven't come across this in any textbook from UK. I don't know about America. I've never seen a textbook. I don't know. Canada, I don't know. In India, again, they use the 180n plus minus 1 power n alpha, 360n plus minus alpha, 180n plus alpha. They don't use PV and SV. I don't know where I picked this up, or maybe sometime when I was in Kenya, I was trying to, I think one of the students mentioned, so that you see, every time you're going to use that value, so why don't you use a symbol instead of alpha? So we changed it, because we knew it's the principal value because of the inverse function, so that's what I used. So what you need to remember is these formulas. And don't worry, if you're really interested in getting an A or an A star in maths, you must be very strong in trigonometry. All types of questions in trigonometry. So you will have solved plenty of questions and equations. And once you solve plenty of questions and equations, you will remember this formula they get embedded here, sorry. So that's one way. Otherwise, as I told you, that card I told you, put this in that card. So whenever you're doing questions, look at it, but after a while, try to close the card, remember the formula, write it, go back to the card and check if you're correct. Because if you keep on looking only at the card and doing the questions, you'll get all your homework correct in the exam. Is it for cos, is it 360 and plus PV and 360 and plus SV? Or is it 180N? Get worried. So the only way to overcome that would be, while you're doing preps for the first or homework or practice, first 10-15 questions, look at that. From the 16th question onwards, close the card, write down the formula. Before proceeding, turn the card and see, oh yeah, my formula is correct. Close the card again, complete it. Next question, do it. Remember I said 15, 16. That means for each aspect of trigonometry, you do at least 25-30 questions so the things settle in your mind. That's my advice, but you have a choice. No, sir, I think I'm very clever. I'll remember these things. I had no problem at all. God bless you. You're one of the gifted ones. Go ahead. Thank you very much. In the next lesson, I'll take examples to show you how to apply these to actual questions. Okay? Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.